All right, so let's take a look at one of the problems from the acid-base mechanism worksheet that we all were afraid of, I guess, in Friday's tutorial. I think the one of the first things you can do with these problems, if you're really having issues, don't be afraid to go through and number your carbons. So it helps it become a little easier for you to see what's going on in these reactions. So let's start from left to right. We call this carbon 1. We got 2, 3, 4, 5, and 6. And then on this side, we'll do the same thing. So first of all, this is a good way to check to see if your teacher has not made any mistakes. The amount of carbons on the left side, and the amount of atoms on the left side should always match the amount of atoms on the right side in a chemical reaction. That's the way it is. So if that comes up on the exam where you find a 7 carbon chain on one side and an 8 on the other, you can raise your hand and call them out, and then you can get free points for the whole class, and then everyone's going to love you and you're going to win. But anyway, in this reaction, that did not happen. You can see that we have a 6 carbon chain on the left and a 6 carbon chain on the right. And one bromine formed 2 bonds in this molecule, right? One to carbon 5 and one carbon 6. And now it only has a bond to carbon 5 in the final product. So this bromine right here probably came from this bromonium cation. And pay attention to this mechanism because you will see it again. This is the second half of the electrophilic addition of a halogen to an alkene. I tried to show you guys this, but it was a little scary. But you will see it again, is my point. So basically, you can see that one bond is broken between one of these carbon atoms, carbon 6, and the bromine. So this bond is broken, and then a bond formed between this extra bromine atom right here and carbon 6 to replace the bond that was broken. So since one bond is formed and one bond is broken, you probably know that you need 2 curved arrows. Now, another thing that I think you should do with these problems that's going to help you out is drawing your lone pairs to make sure you can account for everything. It helps you see what's going on a little better as well. So this bromine here with the positive charge has 3 lone pairs, right? Because 2 lone pairs. 2 lone pairs. 2 lone pairs and 2 double bonds for bromine gives it a formal charge of positive 1 because it has 7 in the neutral molecule, and now it has 6 valence electrons in all the bonds in lone pairs. So it has positive 1. And then this bromine is going to have your 4 lone pair because it has this completed octet. And so basically, after all that thinking, all you have to do now is draw in the curved arrows. And if you can see that all these transformations have happened, then it should make the last part very, very simple. So like I said, the bond between carbon 6 and the bromine, the positively charged bromonium ion, has broken. So those electrons are going onto the bromine because it's more electronegative than carbon, right? So that you know that those electrons aren't going to go onto carbon or anything. That wouldn't make any sense. So then removing these electrons has taken electrons away from this carbon 6, right? So to compensate for that, we bring in the electrons from the lone pair of the negatively charged bromide ion, and that'll give you the transformation. So all in all, I'm going to draw it again to make sure you can see what really happened, because I know that's very, very messy. Let's see. So we got a bromonium ion and the bromide. I'm just going to draw one of the lone pairs here. And here are your curved arrows. One from the C6 to positively charged bromine, and one from the bromide ion to give you the product. 4, 5, 6, and a bromine. What did I just draw? 1, 2, 3, 4, 5, 6. I drew this one a little uglier. Oh, wait, no, there it is. Sorry. 1, 2, 3, 4, 5, 6, and the other bromine. And that's this problem. All right, I hope this helped.